This question describes a relatively simple probability experiment that can be used to illustrate the expected value formula. Remember, expected value is relevant when you have an experiment that has numerical outcomes and you can compute the probabilities of those outcomes. And that's exactly what's going on here. We're drawing a card from a box at random, and the cards are numbered from -2 to 4. So I have 7 outcomes here. The card I pick out could be numbered -2, -1, 0, 1, 2, 3, and 4. Because there are 7 cards in here, and each one is just as likely as any other to come up, the probability for each of those outcomes is 1/7. The reason I'm writing it this way is I'm kind of trying to illustrate what I think is a good organized way to deal with an expected value problem. List what the numeric outcomes are along with their probabilities, and then all we're going to do is multiply each outcome by its probability and add the results. So I get -2 times 1/7 plus -1 times 1/7 plus 0 times 1/7 plus 1 times 1/7 plus 2 times 1/7 plus 3 times 1/7 plus 4 times 1/7. Now it's just an arithmetic problem, and I'll kind of help myself by observing that I've got a bunch of fractions that all have denominator 7. The numerators are -2, -1, 0, 1, 2, 3, and 4. So in the numerator, maybe I should have made this fraction bar much longer. The numerator is going to end up being -2 minus 1 plus 0, which I don't need to write, plus 1 plus 2 plus 3 plus 4. And that works out to be 7 in the numerator. Divided by 7 is 1. So my expected value from drawing one of these cards at random is 1.